Digital twins are replicas of physical objects or processes that model the real world. Manufacturers can use them to perform simulations to improve results and reduce costs. To learn more, download a free white paper at insidehpc.com/Lenovo-podcast. That's LENOVO-PODCAST.
I expect lots of AI, and of course, ChatGPT has been taking the internet by storm.
It was otherworldly. It was very science fiction looking, almost like in a steampunk 1950s sci-fi.
While better technology allows you to spend less energy for whatever it was you were doing, you're doing a lot more of it in a smaller area.
Global Market Insights estimates that for the data center industry in general, not HPC, but it's a $2 billion industry as of last year, and they expect it to surpass $12 billion in 10 years.
From Orion X in association with Inside HPC, this is the At HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hey, Shaheen, great to be back with you.
Great to be here again. How are you?
Very well, and we're now in May, and May means it's ISC month. So a lot of us are looking forward to being in Hamburg later this month at that conference.
Absolutely. Looking forward to it. I'll be virtual this year again, but definitely looking forward to what's new this time.
Well, we'll miss you over there, but certainly if the new top 500 list will be coming out, my guess, and my predictions are almost always wrong on everything, but I'll make another prediction, which is I think it'll be a pretty static list, especially toward the top.
No Aurora, you're saying?
I don't think we're expecting Aurora to be part of it. Maybe not till November, maybe even not till a year from now.
I see.
Install goes. Now, their testbed system,
I was just going to say.
Right, that could qualify, but I don't know where that would come in.
Yeah, well, the Frontier testbed system made it quite nicely to the Green 500. So maybe Aurora would do something similar. I don't know. It would be nice to see something.
It would. And when Aurora does come in, they're expecting 2 exaflops, so it will leapfrog Frontier on pure throughput. But again, I don't think we're expecting it this month.
Yeah, well, it better meet that window, right?
Mm-hmm.
And I'm glad that the testbed is there. The photos that folks were posting look like there's a lot of activity in the boards showing up and being plugged into systems. So fingers crossed, right?
Yeah. Then it'll be fun to see, too, with AI so intensely, the focus now, and generative AI, how that plays out at the conference and what people will be saying, how they play into that.
Yes, I expect lots of AI. And of course, ChatGPT has been taking the internet by storm. And soon it's going to want to do supercomputing by itself. So it'll be interesting to see what uses people have put that in for. And the other thing I'm looking forward to is the integration of quantum computing with supercomputing, and where that's finding its place in the ecosystem would be really nice, especially because the Europeans are pretty strong in that area and ISC is in their backyard.
Yeah, and I think we'll start to see results from some of these very high-end supercomputers in Europe, like the Leonardo system in Italy and Lumi in Finland, because those systems now have something of a track record to boast about, maybe.
Yeah, I think they're doing a great job. The other thing is the chip manufacturing capabilities in Europe and the European CPUs. It'll be nice to see what those guys are doing.
Cyperl.
Cyperl, exactly. Yeah.
Mm-hmm.
What the Barcelona Supercomputing Center, they had some good efforts there.
Yeah. Okay. So the topic of conversation today is liquid cooling in HPC. And it kind of builds on our last conversation with your colleague, Adrian Cockcroft, where we talked about ESG and carbon from a big picture perspective. And liquid cooling, of course, is a piece of that, in the sense that liquid cooling certainly cuts down on energy consumption. It's lower cost and much more environmentally friendly.
Yeah, I thought that the conversation naturally led to cooling, and we didn't have time to cover it in that episode. So it's a great idea to pick it up this time. Now, I think that the lower cost part of liquid cooling, I think, is a bit of a debate because it's certainly more expensive to install.
Yes.
And it's a little bit more complicated to operate. But the expectation is that over time, it pays for itself.
Yeah.
And on top of that, it has environmental benefits.
Yes, the payback over time. I think my most impressive experience with liquid cooling was being in the presence of the Frontier supercomputer at Oak Ridge last year. In part, liquid cooling in two ways. One was that we went downstairs below the computer room,
Mhm.
and I've never seen such gigantic piping system to convey the water in and out of that system. It was otherworldly. It was very science fiction looking, almost like in a steampunk 1950s sci-fi movie kind of way. But secondly, when you're around Frontier and it's running, it's not noisy. It's almost,
No
it's
fans. Yeah.
no fans. It's the biggest system in the world as a very quiet computer room. It was amazing.
Right. That reminds me of Cray Research had a data center in Mendota Heights way back when. And if you went below the data center floor in the basement, something similar showed up, massive piping and refrigeration and flow. And it was really quite a sight. Very, very impressive. And I bet Frontier is just way above that. And that was already pretty impressive. Yeah.
Yeah.
Yeah, this reminds me actually that with the power efficiency unit, the PUE that they measure, presumably the one that is measured for air cooling includes the energy used for fans, but for liquid cooling it doesn't. So it turns it into a bit of an apples and oranges thing that one has to keep in mind. That's kind of one of the
So in that sense, are you referring that the PUE does not account for the power required to move the water for these liquid systems?
That's what I understand, that it includes the fans for air cooling, but not the pumps for liquid cooling.
Oh, that doesn't seem fair.
Well, I think, these standards get set when they get set, and then it becomes hard to change them because everybody's been measuring it in a particular way.
So, Sheen, let me ask you on point of interest. When did liquid cooling kind of enter the data center industry, would you say?
Are you asking for a year or like what era? Because I imagine this was with some of the early mainframes, if I'm not, that would be where my guess would go.
You're on the right track, yes.
All right. Well, then that could be as early as, mid 50s, or is that
Well,
too early?
a little too early, yeah. From what I've read, it was 1964.
Aha, aha.
IBM announced its first water-cooled product for mainframe. And it's
Yeah.
funny because as recently, say, as 2017, I remember speaking with vendors about their liquid cooling capabilities, in the server industry, and really still at that point combating the notion that water cooling is risky and unsafe, inherently unsafe. They were making the case aggressively that that's no longer true. So we're talking how many decades later?
Yes. Well, I think there was a time when the technology that was used for mainframes and really the technology that was necessary to achieve speed, the emitter coupled logic for a while, ECL, was just running hot. And when CMOS technology came along, it was just fundamentally cooler. You didn't really need it anymore. But in the old days, when you bought a mainframe, you got several frames, of which the computer was the main frame. That was always the way I understood it anyway. And that included a cooling box and a power box and the computer box and the storage boxes. And that was a big deal. Absolutely. You kind of needed refrigeration, chilled water pulled into the data center, raised floor, the whole bit. And that all went away when you had different technologies until we reached the limits of that.
I see. Although now we're hearing estimates as high as 70% within HPC systems, liquid cooling is being deployed. Now, in what way, we're not sure. It's just sort of a general observation.
Yeah, I kind of see it as you would expect from me. I sort of like a linear spectrum to center myself and what I think. I think at one point you just air condition the data center.
Mm-hmm.
And that air conditioner obviously uses fluids. So you could say that my data center is liquid cooled. Well, okay, it's got air conditioning. So there's that. Then the next phase after that is that you have these boxes and racks, and these are running hot. So you chill the doors. You don't need to chill the computers themselves, but you chill the environment in which they reside. And that is a technology, certainly, that can work very well, and it's pretty attractive for many applications. Next step after that is when you run a pipe over the circuit board itself, or you actually have a power cooling dissipation on top of your hotspots, which are usually the CPUs or GPUs. And that's direct to chip, D to C. So the next step is a so-called vapor chamber or an adiabatic cooling tower, which is essentially an enclosed, very, very flat enclosure that attaches itself to one side of the box or another side of the box, or you could put circuit boards on it, just kind of wedge it on top of that. And that has liquid in it that vaporizes when it gets hot. So it actually gathers a whole lot of heat by doing so when you go through a phase transition. And it cools back down when you cool it, or you have a fan outside that cools that. So vapor chamber is the next one. The one after that is immersion cooling, where you put the circuit boards inside a liquid cooled, and that liquid can be carbon-based or fluorine-based, depending on what you want. If it's carbon-based, it actually could be mineral oil or like biological oil. It makes it smell like you're cooking something. And that immersion cooling can be single phase, where it's just liquid gets warm and then circulates out of the container and gets cooled and gets pulled back in. Or it could be a two phase, where the liquid turns into gas and then it basically forms clouds and then it gets cooled and then it like rains back down. And that is more efficient again, because you could take a lot of heat out when you go through a phase transition. And then finally, you do the whole data center that is like liquid cooled, and you got all these refrigeration for the data center is more liquid based than just air conditioning. And then ultimately you have the whole data center underwater, as has been done when you put a container at the bottom of the ocean when it is pretty cold. So I think all of those give you the right to claim liquid cooling. Exactly what is included or not is, I think, in the fine print usually.
The manufacturing industry is poised to take a giant leap into the future with new technologies such as digital twins. Download the free white paper, HPC in Manufacturing Using Digital Twins with NVIDIA, to learn how Lenovo EveryScale OVX solution for NVIDIA Omniverse enables manufacturers to take CAE to the next level and embrace digital twins by integrating CAE with other digital technologies. To learn more, download a free white paper at insidehpc.com/Lenovo-podcast. That's LENOVO-PODCAST.
Well, we looked around for market numbers. Global Market Insights estimates that for the data center industry in general, not HPC, but it's a $2 billion industry as of last year, and they expect it to surpass $12 billion in 10 years. So it's a CAGR of 15%. We're typically seeing CAGRs of 15 to 24%, 25%. So it's definitely growing. And, to Adrian's point in our last episode, that on a per watt basis, the IT industry is really holding its own. It's kind of plateaued. Again, I think this is a piece of the solution.
Yeah, I think the IT industry is doing a very, very good job of staying on top of this. One thing to note too is that chips are actually becoming hotter. And we've seen with the GPUs, there was a time when pushing 200 watts per chip was like a lot, and then it was 300, and then it was 500, and now it's like 700. And the most recent news I heard was with tiles and chiplets on a substrate, we're now looking at 2 kilowatts per chip. And how many of those can you put in a rack? At the rack level, 10 kilowatts per rack was the standard for a good while. And then the HPC sites kind of pushed it to 20 kilowatts, and now it's like higher than that. And so it's all getting more and more difficult to cool. Of course it is, because it's density, because while better technology allows you to spend less energy for whatever it was you were doing, you're doing a lot more of it in a smaller area. So the density is really what's causing cooling to be an issue. I mean, you could imagine if you could spread it across a mile, then you didn't have to cool it. But when you put them all in 1 square inch, then you do have to cool it. So that's an interesting way of thinking about it.
Yeah. I've written about this technology off and on. I know that some of these liquid cooling systems, they use not just warm water. Well, they don't use cool water, and they don't use just warm water. It's actually hot water. The water is more than 120 degrees being used to cool these systems. Shaheen, I don't know if you can explain to me, how do you cool something down with 120 degree water?
Well, you make it even hotter. Right. That's how the air conditioner works in Arizona when it's 120 degrees outside and it's 60 degrees inside, is because the fluid outside starts hot and it gets even hotter and gives that temperature back to you. It's pretty interesting that these things work from a thermodynamic standpoint, and depending on whatever coolant they're using and all that.
Are there new techniques on the horizon or relatively recent innovations in liquid cooling that are being adopted that you know of?
I think immersion cooling is the one that's always been around the corner, and there have been at least a couple of data centers that I'm aware of that have been using it in a big way. One problem with liquid cooling in general is that it's got operational complexity. You could have leaks, you could have vapor escapes, you could make it difficult for service operations if you need to remove a board and put it back in or fix it. So that adds cost and complexity, and
not to mention plumbing, I would say.
Exactly. Also different plumbing. Also, when you have a container full of liquid, it's very heavy. So you can't really put it way on top of a rack. How do you bring it back down? So either need sort of mechanical help to push it up and back down, or you just standardize in a data center that doesn't go very high up, that you got all these pools of liquid container that are accessible at normal height. And if you standardize that across the data center, then it works. And now you get the benefit of that economies of scale because your service processes are the same and everything you need to do for inspection and all of that are more consistent. If you do that, that really works. Another place where I've seen immersion cooling really works is where all the GPUs are immersed in fluid and they're getting cooled, and that's the only part that you really need to cool. So you basically consolidate all the parts that are running hot and you immersion cool just those parts. And if you want to use them, your CDI allows you to go and compose them into the system that you want. Those are pretty novel uses that I like. The vapor chamber I mentioned is also pretty novel. It's extremely good, especially for edge devices. So there are definitely new technologies coming in. Also, how do you drive fluid to the actual chiplet and back? There are like startups working on that too.
Yeah, interesting stuff. I mean, I think it's incredibly well established that using a lot of fans and air conditioners is an incredibly inefficient way of dealing with HPC level. The figures we typically see is, in the end, 30 to 40% cooling cost reduction. But as you say, there's higher upfront costs. So it's a matter of where do you reach that break-even point and then move into actual savings.
Yeah, what I've seen generally is a total cost of ownership kind of calculation, that It does cost you more upfront, but then it pays for itself and it's got environmental benefits that sometimes are very important for the organization, and hopefully they are increasingly. Then the next thing really is the vendors and who are the players that are in the space. And I'm not going to remember all of them, but I basically categorize them based on those who are in North America, those who are international, those who have immersion cooling as an offering, and then the big guys.
Mm-hmm.
And then the big guys all have something or other. They all offer it. They probably get it from somebody. Many of them have labs that have done advances in this kind of a technology. Whether or not they've productized them is a separate issue, but they certainly have the expertise. So you've got folks like CoolIT and GRC and Liquid Cool Solutions. You got people like Submer and Liquid Stack and Green Revolutions. They do immersive. And then international, we have Acetech in Denmark and Aspertis in Holland, Allied Control in Hong Kong. Verne Global is a data center provider with geothermal, but they show up. They're in Iceland. And then of the big guys, you've got really all of them, Fujitsu, IBM, HPE, Lenovo, Dell, etc.
Yeah, it's everywhere. And it's certainly everywhere in HPC. Okay, well, interesting discussion, Shaheen. Thanks so much, and great to be with you again.
Well, look forward to Top 500 and ISC. Thank you.
That's it for this episode of the At HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The At HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.